have to, it's a good experimental design problem actually, because they got to figure out how do they distribute the treatments among the houses, and this leads to a discussion of blocking again, and numbers of replicates among houses, and in terms of reliability, and so on. It works fine. We found that the dorm rooms are very tiny, and so they can only hold a few plants, so giving them bench space was less limiting. Okay, so this, somewhere in this process, sometimes it comes up right away, more often than not it comes up much more toward the end of this project. We tackle some of these bigger questions. I posed a question to them. I said, well, are eco-friendly products really eco-friendly? What does eco-friendly mean? So, because they already have an idea fixed in their head of what eco-friendly means, but that's not the only way to be eco-friendly. So, for example, they're testing things like, for lack of a better term, we call it toxicity. They're measuring some kind of biological impact, right? But that's not the only way it can be eco-friendly. It can be eco-friendly because it just takes less energy to produce that product. Or it's recyclable. The packaging that it's sold in is recyclable, whereas the other one isn't. You know, there are lots of ways to be eco-friendly. You wouldn't test them all the same way. And then these are more important, the second bullet here. So you've done a test. You've actually come to some conclusion about it, and I'll show you some of their conclusions in a minute. Was it a fair test? Is that really a fair way of testing whether these products are eco-friendly? In other words, you've chosen some very particular measures on a very particular system, and from that you're making an inference, a much more general inference. Well, how justified are you in making that general inference? Is that fair? Are you being fair? Or more generally, what are the limits of inference? When we talk about the impact of excess nitrogen in the environment, we are drawing on a very long history with a huge amount of data of successfully extending inferences from one particular field and one particular kind of plant to others. This is a case where we don't really have that broad base of background to be able to extend those inferences. Maybe our inferences should be a little bit more modest at this stage, given the data that we have. All right, so here I'm going to show you 3 examples. Like I said, there's 130 in the class, so that adds to about 30, I think, posters that they do. They present it as a poster paper, and they get a little bit of instruction on what are the principles of making a good scientific poster. Not that they always follow those. we give them some idea. And they put them up on the walls of the class, and then I'll go around, Kim has helped me at this before, we go around and grade these while the students are doing a peer review of them. What would I point out about this particular? So let's start with the title here. Eco-friendly soap doesn't measure up. In their case, they tested one eco-friendly soap and one regular dishwashing soap at 3 different concentrations. And I don't make them do any statistical analysis of this because they haven't had statistics yet, even though I make them read a very small book on statistics. But they came to the conclusion here, without any statistics, that there really isn't a major difference in the performance of the 2. There's one of the things that's nice is a graphing exercise, I find. When they're given no instruction, I don't tell them at all how to present their data. You find that this is a weakness of theirs. That they're good. If you tell them, here are a set of data, draw a graph like this, they can do that fine. But if you don't tell them what kind of graph at all to do, they come up with some of the more bizarre ideas I've ever seen. Some of them are just simple things like not labeling stuff, but usually you get past that fairly quickly. Let's go to the next slide, I think. Here's a good example. So here, to be or not to be. Let's just start with the graphs up at the top right here are showing you, I don't know why they would have thought to plot it this way, but they're trying to plot, I believe it's the height of the plant. They're describing it as length. But rather than summarizing this as some sort of mean height for each of the groups, they've rank ordered the plant number, which is obviously just an arbitrary type, an arbitrary label, and plotted each individual one like this and tried to describe whether these 2 lines are different from each other. You know, strictly speaking, it's not wrong, but it's not the way that one would want to present these data. That's a good format to discuss data presentation with them. They come to the conclusion, you can't really see it in the slide, but in this sort of lower right-hand one here, this is the highest concentration of the two products that they use. And it happens that the line on the top, the tallest one, is actually the conventional liquid, not the eco-friendly one. So they're coming to the conclusion here that actually the eco-friendly product is worse than the conventional one. The other thing that this, so they did, by the way, they did shampoo in this case, was the product. The other thing that's nice about this is a layout of their bench space, and that shows you that they haven't dispersed their treatments. They've lumped all their treatments together in space, and that's a nice way then to describe, well, you know what? Suppose that this bench is oriented in such a way that this is the window, and there's more light over here. Well, these two treatments are going to get more light, and they're going to grow more, even though the treatment has nothing to do with it. And that you can only protect yourself against that by interspersing your treatments, or randomizing, really. Have a discussion of that. Jason? I'm not doing for time, by the way. Sorry. Okay, last one. Are you being greenwashed? They used, this is laundry detergent, and they used two eco-friendly detergents and one non-eco-friendly, one conventional detergent, and actually come to the same basic conclusion at some concentrations, at this concentration, that the conventional product actually needs to work. I think they're using dry mass or wet mass here. So the plants are heavier if they're grown with conventional laundry detergent than with eco-friendly laundry detergent. I just picked these 3 examples out of 30. Some people found the opposite results. It's not really important what results they found. It's not even really important if they found any results. What's important is to have gone through the exercise. In fact, one group killed themselves. What's important is to have gone through this whole exercise, to have had those discussions, to have gone through that thought process, and to have presented and discussed your results and what you could do better, how would you do things differently the next time through. Okay, so just two slides, 2 minutes on my experiences teaching first-year students. So they do a lot of writing in my course, and I would say that they are very good at expository writing. They are very poor at critical writing. I'm not sure why that is, but that's my experience, so we really have to start at the ground level with them. Part of it is just to get them to understand what an academic argument means. They confuse that very often with debating, and the two are not remotely the same kinds of thinking, in a sense, or presentation. Getting them to understand that it's their responsibility in critical thinking and critical writing, which are the same thing, I would say. Getting them to understand it's their responsibility to sympathetically reconstruct the argument of those people that they disagree with. And that's important, to sympathetically reconstruct, not just to parrot it back, not necessarily even to use their own words, but to present it in its most sympathetic light, and then to show why they think it's wrong. They have a hard time, even with that concept, of doing it. They also have this weird idea that scientific objectivity means that they shouldn't have any of their own ideas. That even that using personal pronouns is wrong in science writing. I'll show you an example in a second. What they're very good at is doing things like this first sentence. They'll write, Odom said X, and that'll be the end of it. And what I want them to write is, Odom said X. I think X is likely to be correct because of A and B. It's that second sentence that I don't get, and that's what I'm teaching them to